modeling is what we do once we have the designs ready. This is a cottage from Ratatouille, where we create the 3D geometry for the assets. Now, as many of you guys know, like a model like a house, it's like sculpture. You start with a cube, you extrude faces, you divide them, maybe you start duplicating planks, but there's only so much the computer can do for you automatically. This is something you can do by hand, but there's only so many featured assets like that. For things like environments, the job of the modeling team can get a little more complicated, where look at all these different types of coral out there. This sometimes can be too much to model by hand, so the modeling team might actually try to automate the process by doing a little programming to say, write a program to generate a plant where you might have higher level parameters like how tall it should be, how many branches, and what's the random angles between the branches and so on. And it also can be tricky to represent. Many of these are more curve-based modeling, not traditional extrusion-based modeling. So there's a wide range of skills potentials in modeling. Some more straightforward, some a little trickier as in environments. Speaking of environments, we do have set dressers that actually place many of these assets into the real shot. So you might not think this is very hard, but look at all that sagebrush in the desert there. There's actually a lot of work goes into just putting these together, used in the shot. So set dressing is typically positioned in the layout department and can happen once the modeling is completed. Now, mostly we talked about set modeling. We also have character modeling, as in the case here with, I believe this is the character Marlin from Finding Nemo. And often what character modeling does is get some very specific drawings from art. In particular, we call these a model packet. We break down what the fins look like, and which component the fin is like, and what the character shape is, and from various angles. And the character GD creates the model. Now, if it were just a single fish, and you had to get a single shape right, that's okay. But character modeling can be a lot trickier than set modeling because all of the placements of the polygons, these are the vertices and edges, have to be in reasonable places for rigging, which is the department that adds the animation controls. So for instance, if you want to bend like a fold in the eyelids, a fold can only happen where there's a span in the mesh. So modeling and rigging are very, very closely tied together. So it's actually the same job at Pixar. There's no people that are just character modelers. Everyone who does character modeling also rigs the character because they're so closely tied together. This is not the same at every studio, but in Pixar, that's how we do it. And to talk a little bit more about rigging, here's Bob, or Mr. Incredible, for The Incredibles, and typically you break the body into regions that an animator might want to control. And like upper chest, torso, and you have things like rotates and scales and bulges and various kind of controls and parameters that can move the character around and influence sort of region by region. And these controls might look something like this. We also might create a muscle system on top of it. We actually don't do this very much anymore, but we did on Incredibles. And then we also have to think about rigging the clothing, and this just shows you, I guess, all the level of controls that go into that shot. But more often though, riggers basically take a region of the body and associate points on the body with controls on it. And then the animator can animate those controls to create a fully fleshed out character. So that's rigging and character modeling and right there. So while that's going, however, we also can have artists that are working on shading and paint, which creates the materials for the object. Now this is a topic I'm going to talk about in much more detail in a later part of the lecture, but for now you can think of shading as the material on an object. In this case, the material would be sort of chipping paint. And just like a rigger might create controls to move a character around. You know, where's the chest, where's the wrist? A shading team will create controls to modify the material. So in this case, the controls on this shader will be how old and how chipped the paint should be. And I'm going to go through these slides that increasingly make this look older and older. And you can see now, you know, with those controls cranked up, we see a lot of aging. So the shading team might use many tricks from even simple things like painting a map to things where, like using a noise function and a remapping spline and a blur to sort of create bubbly paint. And there's many reasons why you choose one technique for another. I don't want to cover that right now, but later I'm going to talk a lot about how to create effects like this in shaders. However, it all starts with reference, and this is true for most departments, but in a film like Cars, we'll take lots of pictures of real cars and what real car paint looks like, and then figure out what we need in our materials. And one effect you see on cars, particularly flashy cars, is what's called metal flake paint, where we sort of worked hard to get sort of a sparkly paint, where the shape of the light is kind of very clear, like a rectangle, but you sort of have a halo of sparkle that's kind of colored surrounding it, which we observe from the reference. So that's one of the things shading paint does, is figure out, you know, various kind of ways materials to interact with light to make it look believable. And if people have questions, I can talk a lot more in detail about how, say, a car paint shader might work. You know, rusty materials are very interesting too. This is some reference that we used for the character Mater, and he is a rusty tow truck. So yeah, we photographed lots of rusty trucks and figured out how to make materials like that for him. So shading the paint, while that's going on, assuming that editorial and modeling has done their job, we can also do layout. Now in layout, we have to go from, on the upper left, that's an art drawing of an entire scene where the camera is supposed to move through that. And in the storyboards, that's usually what they do. They'll maybe do one drawing, zoom into a portion, and kind of pan across. However, that's not real filmmaking, that's just sort of previs. Layout has to actually set up real cameras in a 3D environment and move them and choose lens angles and do cutting and turn what might be a single pan across a drawing into a number of shots with different cameras where the characters are staged correctly. So layout places the camera, makes sure everything's been shot, and you know, it's essentially, layout is like traditional cinematography, really. You film shots, you choose cuts, you choose lens angles, all degrees from filmmaking, like, you know, the 180-degree rule, stage direction, things like that, have to be observed in CG film direction as well. So actually many of our layout artists come from more traditional film backgrounds. Here's an example of other shots that were done by layout. Now, what Pixar is often known for is animation. And here is a little, so we do plenty of animation. And it's worth noting that our animation is still using the very traditional principles. In particular, believe it or not, John Lasseter wrote a research paper in Cinegraph 87, and John Lasseter being one of our directors of animation background, that talks about how all of the traditional principles of animation, like timing and motion,